How to build a smart contract. It performs 100 functions simultaneously without getting tired, and practically the entire Web3 industry relies on it. Do you understand what we're talking about? To find out for sure, watch the video to the end. Meanwhile, for the Web3 project developers and leaders, the question of developing their own smart contracts becomes increasingly important. How difficult, costly, and time-consuming is it? Can you try writing one yourself? Let's delve into it. Developers of virtually any Web3 project need to have knowledge of how to code and deploy a smart contract. Since Ethereum is one of the most popular blockchains for such development, we've chosen it for this step-by-step guide. Watch and take notes. Step 1. Connect to the Ethereum network and test network. As a user in the Web3 space, you likely have a built-in browser wallet like Metamask. Connect to the Ethereum network. In the future, you will need to test the smart contract you've developed, so it's a good idea to choose one of Ethereum's test networks and switch to it when conducting tests. In the list of available networks, you can select the Girly testnet or manually add any other Ethereum test network. Step 2. Fund your balance with Test ETH. You can obtain test tokens for the Girly network through a faucet on the website girlyfaucet.com. Simply paste your Metamask wallet address into the address field and acquire tokens. However, remember that your balance should be at least 0.001 ETH for a successful transaction. After receiving tokens, you will be able to test the smart contract you've created. Step 3. Open Remix IDE. You can create a smart contract without leaving your browser by using the Remix editor in Solidity. This editor is excellent for writing basic smart contracts. Just go to the official link remix.ethereum.org to access the code editor. To start working on a file, click on the Create New File icon under Default Workshop. Step 4. Create a Sol file. Smart contracts are written in Solidity, so the file format should have the Sol extension. Name the new test file hostel Sol, and you'll have a workspace where you can enter lines of code. Step 5. Start writing code. The basic structure should include the elements we will describe below, but you can customize parameters based on your project's needs. First, you need to provide the Solidity version in the smart contract. Now create the main contract, name hostel. Inside the contract hostel, follow the steps below. Create some variables where the smart contract will store the payable address, 42-character hex string with prefix 0x of the landlord and the tenant. Then create some public variables where the smart contract will store integer values. For this, use the data type int, 256-bit unsigned integer. After that, you should create a structure to store details of each hostel room, including hostel, number, name, address, total agreements, monthly rent, one-time security deposit, last agreement sign time, vacancy, landlord address, and current tenant address. Don't forget to map this structure with the int. Similar to the above, create a structure for each rental agreement and map it with the int named agreement ID. Store details as provided on the screen. Code a structure for each rent payment and map it with the int. This will store details like rent number, hostel number, agreement number, hostel name, hostel address, monthly rent, rent payment time, landlord address, and tenant address. Use some modifiers that will help you verify certain conditions before running a function. The required statement means that if the given condition is not satisfied, the function won't execute, and the given string will appear as an error code. Some of the presented modifiers will help you understand whether the action is executed in the smart contract. Here, require means that if the given condition is not satisfied, the function won't execute, and the provided string will appear as an error code. The only landlord modifier checks if the message sender is the landlord. Conversely, the not landlord modifier will check if the message sender is anyone except the landlord. The only while vacant modifier will show whether the room is vacant or not. The enough room rent modifier will check whether the tenant has enough Ether in their wallet to pay the rent. The useful agreement times up modifier will indicate whether 365 days have passed since the last agreement was created. You can find a full list of functional modifiers on the Solidity website at soliditylang.org in the Structure of a Contract section. Be sure to include several important functions in the code. Start with adding rooms. Then you can implement the sign agreement function to sign the rental agreement for a hostel room between the landlord and the tenant. This function has some features that you should take into account. The function will only execute if the user is a tenant, meaning that the user's address and the landlord's address do not match. The operation will not proceed if the user has enough payable Ether in their Ethereum wallet. The concept of enough Ethereum includes the one-time security deposit plus the rent for the first months. Also, the sign agreement function will only execute if the said room is vacant and the tenant has enough Ether in their wallet. Now let's add the pay rent function, which the tenant will use to pay the monthly rent to the landlord. Before creating the pay rent function, please keep in mind that the function will only execute if the user's address and the previous tenant's address are the same, meaning that the user can only pay rent if they have signed an agreement with the landlord within the last 365 days. The tenant must have paid their previous rent more than a month ago. The user should also have enough payable Ether in the Ethereum wallet. Another function, agreement completed, will allow the landlord to mark the agreement as completed. In this case, don't forget that the landlord's and user's addresses must match, and the agreement must have been signed more than a year ago. Finally, the agreement terminated function is needed for the landlord to terminate an agreement. The function will work under the same conditions as the previous agreement completed function. Step 6. Compilation and deployment of the code. To compile the code, click on the Solidity Compile option in the left sidebar. Select Compile version 0.5.16+ and choose Compile hostel.sol. To deploy your smart contract, select the Deploy and Run Transaction option in the left sidebar. Choose the environment that suits you from the drop-down menu and adjust the gas limit if necessary, which is set to 3 amp by default. Step 7. Preparations to go live. To prepare a smart contract to go live on a blockchain, procedures such as testing or auditioning are strongly recommended, besides other considerations. Once reassured that the smart contract is ready to hit the markets, the smart contract can be deployed to the Ethereum mainnet. Now you have a step-by-step guide on creating a smart contract, from simple Ethereum connection to implementing modifiers and functions that work seamlessly. Try creating your first test smart contract on Solidity, and even more valuable information for project developers awaits you in our upcoming videos.